Hi friends, good morning. Welcome to my channel Balu Master. Today I am going to discuss definite integration proofs. This is a very important topic for second PU students and this contains 6 marks valuable. So can we start the proofs? Look at carefully. The very first proof is integral a to b f of x dx is equals to integral a to b f of t dt. This is the first proof. So very simple friends. So we are going to discuss these proofs in there are two ways. One is substitution method and one more is formula method. So for which proofs we are going to follow by using substitution, for which proof we are going to follow by using definition, you have to know. So what is the definition of definite integration, you have to know. So what is the definition? Integral a to b f of x dx can be written as capital F of x between the limits a to b. This is the definition. Means what is this meaning? Integral a to b f of x dx. If any function is there, after integration that function will changes to some small f of x can change to capital F of x between the limits a to b as usual. Lower limit is a, upper limit is b. Then if you substitute upper limit minus lower limit, this is the which proofs by using substitution, which proofs by using this definition. Clarity is important, friends. I will explain very clearly. Listen carefully. Coming to very first question, integral a to b f of x dx equal to a to b f of t dt. So very clearly, f of x, f of t is there. So in place of x, just a t is there. So this kind of proofs you are going to solve by using substitution only, not by using definition. So I'm not going to apply definition here. Substitution only. The substitution also very clear, friends. X as t. That's all. So you are going to take put x is equals to t. Differentiate with respect to x. So dx is equals to dt is the substitution. Whenever you are taking the substitution, you must change the limits. That is the property in definite integration. So what are the limits here? Limits are as x tends to a, as x tends to a, which implies t tends to. So lower limit is a, upper limit is b. As x tends to a, as x tends to b. Then what about the t behavior? If you take x as a, t is also a. If you take x as upper limit b, t is also b. So let us take the left hand side. A to b f of x dx is equals to integral a to b. A to b means yes, a only, b also remains b only. So that's what it doesn't change. F of x can be written as what? T. And dx can be written as what? Dt. So that's all the proof. Integral a to b f of x dx is equals to integral a to b f of t dt. So what is this meaning of this proof? Means if any function completely in terms of t, we can able to change in terms of x also. For example, any function in terms of x, we can able to change completely in terms of t. That is the meaning of this proof, friends. Did you clear? So this proof usually they never ask in the examination. Let us move to integral a to b f of x dx is equals to minus integral b to a f of x dx. Isn't it? If you see very clearly, so f of x and this is also f of x. Both are f of x. Both are same, means it is not by using substitution method. This is only possible by using definition. So how can you apply the definition? Look at carefully. Let us take the left hand side, a to b f of x dx. So according to the definition, we can able to write capital F of x between the limits, lower limit as a, upper limit as b. This can be written as upper limit minus lower limit, f of b minus f of a. Then if you want to prove this one, so you have extra minus sign. That's what, let us take minus common. Very simple logic. So in your proof, minus is there, means you need to take minus common. Then plus becomes minus. This minus part becomes plus. Then if you write first negative, first positive, next negative, you will be getting f of a minus f of b along with minus. Then this can be written as minus f of a minus f of b. Just you apply the definition in the opposite way. F of b minus f of a can be written as f of x between the limits. B is the upper limit, a is the lower limit. So similarly, f of x between the limits. What is the upper limit here? A. What is the lower limit here? B. So this can be written as, again applying the same format in the opposite direction. So capital F of x a to b can be written as integral a to b small f of x dx minus capital F of x b to a can be written as integral b to a f of x dx. That's all the proof. So integral a to b f of x dx can be written as minus integral b to a f of x dx. Therefore, integral a to b f of x dx is equals to minus integral b to a f of x dx, which is very easy, friends. I hope you understood. But this is also just application only. Usually they never ask in the exam. Means the meaning is integral 2 to 3 f of x dx is there. Means if you want negative sign outside, you can write the negative sign and just you can interchange the limits. So we are going to use in such kind of cases. That's all the application. But usually they never ask. The proof number, important proof. Look at it, friends. Third proof is integral a to c f of x dx can be written as integral a to b f of x dx plus integral b to c f of x dx, where b belongs to closed AC. Then how to solve this proof? If you see very clearly, it is whether we can able to do by using substitution or else formula. Now, if you see, this is f of x, this is also f of x, this is also f of x. So nothing is there to take substitution. That's what all functions are same, means your approach is only definition. That's what, by using definition, I'm going to derive this proof. Look at carefully. Integral a to c f of x dx can be written as, according to definition, capital F of x between the limits. What can I write? Lower limit a, upper limit c. This can be written as, so if you apply the formula, upper limit minus lower limit. F of c minus f of v. Now what I want to do here means I want to add and subtract one quantity. What is the quantity? F of c. Just subtracted b, f of b, and added f of b and minus f of a written as it is. If you cancel these two, you are going to get the previous step. Now what can I write? This is one formula, this is one more formula. Just apply the definition in reverse way. So f of b minus f of a can be written as f of x between the limits. What are the lower limit and upper limit? C is the upper limit, b is the lower limit. Plus, in the same way, f of x between the limits, you are going to apply b is the upper limit, a is the lower limit. Now, again, you use the same definition in ulta way. Integral, same limits will follow. That's what this is. B means lower limit b, upper limit c, small f of x dx. Plus integral in the same way, a to b f of x dx. Now, what can I write? This is equals to, both are addition, right? That's what can I write first this one? A to b f of x dx. Plus the second part is integral b to c f of x dx. What it is given data? Integral a to c f of x dx. Therefore, integral a to c f of x dx is equals to integral a to b f of x dx plus integral b to c f of x dx. Very simple proof by using the definition, friends. Let us move to property number 4, which is the most important and number of times they asked in the examination. Integral 0 to a f of x dx is equals to integral 0 to a f of a minus x dx. This is the most important. So number of times they asked in the examination, and moreover, along with this question, they will ask this combination problem also. Let us take integral 0 to a f of x dx. What is your first question? Whether it is solved by definition or else substitution. Look at carefully. This is f of x, f of a minus x. Definitely, it will be going by using substitution, and that substitution also very clear. So what is the substitution means? Just you remember like that. Put x is equals to a minus, don't take x in place of x, let us consider some t, some other variable. Differentiate with respect to x, then dx is equals to constant derivative 0 minus dt. So whenever you are taking the substitution, you need to change the limits as x tends to, what is the lower limit? 0. As x tends to upper limit a, which implies as x tends to 0, then what happened? 0 is equals to a minus t. So 0 is equals to a minus t, and hence t is equals to how much? A. So t tends to a. As x tends to a get cancelled, t tends to 0. So now let us consider the question left hand side. Integral 0 to a f of x dx equal to integral. What you are going to do? So lower limit is 0. In place of 0, what we are going to consider? A. Upper limit a. In place of a, you are going to consider 0. F of x. What is x here? A minus t. And dx. What is meant? What is dx here? Minus dt. Now just keep outside the minus sign. Integral a to 0 f of a minus t dt. Now what we are going to apply, we are going to use property number 2. Just now we discussed property number 2. The property is what? Integral a to b. Since integral a to b f of x dx is there, means you can able to write minus integral b to a f of x dx. Now this property I am going to use in ulta way. Minus a to 0 f of a minus t dt. So if I want to remove minus sign, what I want to do? Just I want to interchange the limits. Means if you interchange the limits 0 to a f of a minus t dt, friends. This is equals to 0 to a. Again, I'm going to use one more property. The property number 1. What is the property? Integral a to b f of x dx is equals to what? Integral a to b f of t dt. Very first property I discussed, right? That property we are going to apply. Complete function in terms of t means we can able to convert it in terms of x. So that's what complete function in terms of t I'm going to use in terms of x. Integral f of a minus x dx. What is the left hand side? Integral 0 to a f of x dx. That's all the proof. It's a very easiest proof. Along with that and problem also need to solve. Then only you will be getting 6 marks. Can I move to the next? Integral a to b f of x dx is equals to integral a to b f of a plus b minus x dx. This is the property. Now how to do this one? Very first question is what? Whether you are going to do by using substitution or definition. Can you see? This is f of x. This is f of a plus b minus x. Substitution or definition? Yes, this is absolutely by using substitution only. Definition, when we are going to apply, this is f of x, this is also f of x, by that time definition. But this is f of x, this is f of a plus b minus x dx, this time substitution, and that substitution also very clear. What is the substitution? Can you guess? Put x is equal to a plus b minus, in place of x, take other variable, that is t. Differentiate with respect to x. X derivative dx is equals to a constant derivative 0, b constant derivative 0, minus t minus dt. Whenever you are taking the substitution, you must change the limits. So what are the limits here? Limits. As x tends to, lower limit is what? A. As x tends to, upper limit is what? B. A will change, B will change. As x tends to A, what happened? A get cancelled, T is equals to B. Means T tends to B. As x tends to B, B will get cancelled, T tends to A. Very simple. Let us take the left hand side. A to B f of x dx is equals to integral. A changed as B, B changes as A. F of x is nothing but what? A plus B minus T into dx is nothing but minus dt. Complete x will be converted into completely in terms of t by using substitution and limits. Now what to do? This minus sign, keep the outside. It will b to 0, b to a, f of a plus b minus t dt. Can you able to guess the next step? To avoid this minus sign, which property you are going to use? Property number 2. So what you are going to apply? If you want to remove that minus sign, you need to interchange the limits. Integral b to a becomes integral a to b f of a plus b minus t dt. So which property? Since integral a to b f of x dx is equals to minus integral b to a f of x dx. Let us move to next. Integral a to b. Can you able to apply what is the next property? Complete function in terms of t, we have rights to change in terms of x by using first property. That's what integral a to b f of a plus b minus x dx. Which property we apply? Integral a to b f of x dx is equals to integral a to b f of t dt. This is the proof. Just now we discussed. So what is left hand side? Integral a to b f of x dx. This is the proof, friends. This is also very important and second priority, second important question this is. So this is also one of the expected question in the final examination. That's all. Property number 5. Can I move to property? Integral 0 to 2a f of x dx is equals to integral 0 to a f of x dx plus integral 0 to a f of 2a minus x dx. So this property is what? Integral 0 to 2a f of x dx equal to integral 0 to a f of x dx plus integral 0 to a f of 2a minus x dx. So let us consider this one. Left hand side, integral 0 to 2a f of x dx. So according to property number 3, if you see here, integral 0 to 2a f of x dx means in between 0 and 2a, a will be there, right? In between 0 and 2a, a will be there. That's what 0 to 2a in between, exactly middle value is a. So by using property number 3, we can split this relation as integral 0 to a f of x dx plus integral a to 2a f of x dx. Did you understand? What is the property? Third property is what? Integral a to c f of x dx. How we split it? So this is nothing but a k c in between, b will be there. So we are doing like integral a to b f of x dx plus integral b to c f of x dx, where c belongs to closed ab. So similarly, in between 0 to 2a, a will be there. That's what 0 to a plus a to 2a f of x dx. Clear? So whenever you written this part, half of the proof is already over. How? You want to prove this one. You already getting this one. If you compare these two, 0 to a f of x dx, 0 to a f of x dx. One part clear. Then the second part, a to 2a f of x dx, 0 to a f of 2a minus x. Means this part, you are going to prove this one. We have to show that. Now we have to show that. What we have to show that? Integral a to 2a f of x dx as integral 0 to a f of 2a minus x dx. Clear, friends? Now what to do? Now what to do? Substitution or definition. F of x, f of 2a minus x. If both are f of x, definition. If not, substitution. That substitution also very clear. You don't need to by heart. What is the substitution? Put x is equals to 2a minus, in place of x, take the other variable, that is t. Differentiate with respect to x. Dx is equals to constant derivative 0 minus dt. Now, whenever you are going to take the substitution, you must change the limits. So, as x tends to, lower limit is what? A. As x tends to, upper limit is what? 2a. So, how a and 2a will change? If you take x as a minus 2a becomes minus a, minus minus cancel, t tends to a. As x tends to 2a, 2a get cancelled, t tends to how much? 0. Now, this substitution and limits, everything is substituted in LHS. Integral a to 2a f of x dx changed as integral. So, a becomes a only, 2a becomes 0, f of x. What is x? 2a minus t dx. What is dx? Minus dt. Minus integral a to 0, f of 2a minus t dt. Clear? This is equals to, I hope you understood. What is the next step? We are going to apply property number 2. Why? Because I want to remove this minus sign. If I want to remove the minus sign, so a to 0 becomes 0 to a f of 2a minus t into dt. This is what? Since by property 2. Okay? You must write down property 2 in the examination. So this is equals to, what is the next step? Everything in terms of t means we can able to change in terms of x. So into 0 to a f of 2a minus x dx. Since by property number 1, very first property. I hope you understood. Now integral a to 2a f of x dx becomes integral 0 to a f of 2a minus x dx. So this changed as this. Whenever you are changing this as this, our proof got overwrite. So now let it be called equation number 1. By 1, you are going to write integral 0 to 2a f of x dx is equals to integral 0 to a f of x dx plus this place we are replaced with integral 0 to a f of 2a minus x dx. This is the proof of property number 6. Integral minus a to a f of x dx is equals to 2 times of integral 0 to a f of x dx if f of x is even function, 0 if f of x is odd function. Clear? So first of all, if you want to prove this one, what is even function, what is odd function, you have to know. What is the even function? The definition of even function is f of minus x can be written as f of x. Then that function is even function. What is the odd function? That is f of minus x is equals to minus f of x. This is odd function. Okay, if you know the definitions, the problem will be very easy. So let us start the proof. Let us consider integral minus a to a f of x dx. Again, I am going to use property number 3. If I want to use property number 3, you need to check minus a and a, in between which value is there? 0. So we can able to split to minus a to 0, then 0 to a. That is property number 3. So in between minus a and a, 0 will be there. So that's what I'm going to write. According to property number 3, minus a to 0 f of x dx plus integral 0 to a f of x dx. Minus a to 0, 0 to a f of x dx. Now let us see carefully. Minus a to a f of x dx you are going to prove 2 times of integral 0 to a f of x dx. This is your proof. If you expand this one, 2 times means the meaning is integral 0 to a f of x dx plus integral 0 to a f of x dx. Right? Sum of these two will be getting 2 times. This is proof number 1. What about proof number 2? You are going to prove 0. So what is this meaning? You are going to prove 0 to a f of x dx is 1. The other one, instead of plus, minus 0 to a f of x dx. Hope you clear? If you cancel these two, you will be getting 0. If you add these two, you will be getting 2 times of 0 to a f of x dx. Very clear. Now, you are getting, according to property number 3, you are getting, this is what? Since by property number 3. So by property 3, you are getting like this. Means which part you already getting? Integral 0 to a f of x dx, integral 0 to a f of x dx. 1 0 to a f of x dx you are getting already in those two proofs. Means this is very much clear. Now what is your modification? You must change only this part. You must change only this part. For example, if you prove this part as integral, the same function you proved, integral 0 to f of x dx, it will become 2 times. First proof over. For example, if you prove this part, whatever box part is that one, minus integral 0 to a f of x dx, both will cancel, you will be getting the second part. Going to do two proofs. One is plus 0 to f of x dx, one more is minus 0 to f of x dx, then our proof got over. Clear? Now what to do? So we are going to derive, we have to prove that integral minus a to 0 f of x dx is equals to integral 0 to a f of x dx, one proof, and minus integral 0 to a f of x dx, one more proof. I hope you understood very clearly. If you prove first one, sum, both are same, sum will be 2 times. If you prove the second one, minus to plus to cancel, you will be getting the second proof. Clear? Now what to do? So now here, what you are going to do, it is look like, this is only the proof, it is look like definition because f of x, but here two proofs you are going to prove. That's what you need to do by using substitution. What is the substitution here? You are going to take, put x is equals to, you need to remember the substitution, x equal to minus t. Isn't it? The substitution is minus t. Differentiate with respect to x. If you differentiate with respect to x, dx is equals to minus t. I told very clearly, whenever you are going to take the substitution, you must change the limits. As x tends to lower limit is minus a, as x tends to upper limit is 0, it will changes like t tends to. If you take x as minus a, minus get cancelled, t tends to a. If you take x as 0, t tends to 0. So can we see now the question how we will change? Integral minus a to 0 f of x dx can be written as integral minus a becomes plus a, plus 0 becomes 0 only, f of x. What is meant by x? X equal to minus t. Dx can be written as minus t. Now minus keep it outside. Integral a to 0 f of minus t dt. Going to apply property number 2, it is nothing but integral 0 to a f of minus t dt since by property 2. Let us move to here by property 1, integral 0 to a f of minus x dx since by property 1. So completely in terms of t, I changed this in terms of x. Now here there are two cases will exist that is nothing but case 1. Case 1 is f of x is even function. Whenever this is an even function, what we can able to write? F of minus x you are going to replace as f of x. Whenever you are replacing f of minus x as f of x, what happened here? Integral minus a to 0 f of x dx is equals to what happened? Integral 0 to a f of minus x you are going to replace with what? F of x dx. So first part is over. Can I move to the second one? Case 2. What is case 2? If f of x is f of x is odd function, second proof. If f of x is odd function. If it is an odd function, what is the meaning? F of minus x is nothing but minus f of x. Then what can I write? Integral minus a to 0 f of x dx change it to integral 0 to a f of minus x you are going to replace with what? Minus f of x dx. Clear? So second proof also finished. Minus integral 0 to a f of x dx. Now minus a to 0 f of x dx we proved first one as well as second one. When the first one, if f of x is even function, you are getting first one. Means this place you are going to replace with this. So f of x is odd function, what we are going to do? So replace in place of that box this value. Means what you understood in the final value. Therefore, integral minus a to a f of x dx is equals to, you are going to copy the question once again. F of x is even function. So 0 if f of x is odd function. Hope you understood. Okay. This is the proof. It is not at all difficult but bit lengthy. That's what you need to be very careful. So, property number 7, which is the most important and which is easy also. Last and final proof, very simple and small. Property number 8 is integral 0 to 2a f of x dx is equals to 2 times of integral 0 to a f of x dx if f of 2a minus x is equals to f of x. 0 if f of 2a minus x is equals to minus f of x. Now how you are going to start the sum? So integral 0 to 2a f of x dx. You have property number 6. Look at carefully. Already we derived that one. Integral 0 to 2a f of x dx is equals to integral 0 to a f of x dx plus integral 0 to a f of 2a minus x dx. You can check it once. Property number 6, that is. I want to use property number 6 here. What is that? Integral 0 to a f of x dx plus integral 0 to a f of 2a minus x dx. Since by property number 6, I am writing this part. If you observe carefully, again the same logic. So what you are going to prove here? What you are going to prove here? So if you analyze the given question, so what to do? 2 times of integral 0 to a f of x dx. What is this meaning? This meaning is integral 0 to a f of x dx plus integral 0 to a f of x dx. That's all you are going to prove. If you prove this is one is negative and one is positive, both will cancel, you will be getting 0. Clear? So very clear. So in this proof, again half of the proof is completed. One is integral 0 to a f of x dx, 0 to a f of x dx is completed. And second part, if you prove 0 to a f of x dx, same as this if you prove 2 times. If you prove minus of the same thing means 0. Clear? So very clearly what we can able to read. Now we have to show that. We have to show that what you are going to show. Integral 0 to a f of 2a minus x dx is equals to, you are going to prove, one is integral 0 to a f of x dx and the second one is minus integral 0 to a f of x dx. If you prove this one 2 times, if you prove this one, both will cancel. Clear? So very clear, this one is if f of 2a minus x is equals to f of x. So what can I write? This is integral 0 to a f of 2a minus x dx can be written as integral 0 to a. In place of f of 2a minus x, you consider f of x. You are getting the first one. Next, case 2. If f of 2a minus x is equals to minus f of x, this thing. So what can I write? Integral 0 to a f of x, f of 2a minus x dx can be written as minus integral 0 to a f of x dx. What you are getting? Second proof also getting. So if you substitute in equation number 1, you will be getting the answer. So therefore, by 1, what we can able to write? Integral 0 to 2a f of x dx can be written as. So this box, if you replace with this, integral 0 to f of x, integral 0 to f of x. So how many times? 2 times of integral 0 to a f of x dx. If f of 2a minus x is equals to f of x. Now, if you substitute this quantity as this thing, you are getting 0 if f of 2a minus x is equals to minus f of x. That's all the proof, friends. This is also very, very easy. But the priority wise, so very important proof is 4th one and 5th one and 7th one. These 3 are first priority questions. Then you can able to prepare 3rd one and 8th one. Did you clear? So this is the priority. Not only these proofs, friends, along with this, the respective problems also you need to solve. So that is also most important. If you want, just you text me. Definitely, I will discuss the respective problems also. Okay. I hope you enjoyed the class and you understood the class. That's all for today's class, friends. Thank you so much, friends. Thanks a lot.